Hello everyone. In this video I am going to work through an independent samples t-test with unequal sample size. So here we go. Researchers want to examine the effect of perceived control on health complaints of geriatric patients in a long-term care facility. 30 patients are randomly selected to participate in the study. Group 1, n equal to 14, are given a plant to care for. Group 1 had control over the plant. And Group 2, n equal to 16, are given a plant, but the staff cares for the plant. So Group 2 had no control over the plant. The number of health complaints is recorded for each patient over the following 7 days. The sample statistics are provided in the table below. Do the data indicate that plant care decreased the number of health complaints? So this is an independent samples test, and the way we know that is because we have two separate, distinct, and independent groups, right? So we have Group 1 that had control over the plant, and Group 2 that had no control over the plant. So these are independent samples. This is also a one-tailed test. How do I know? The question tells me. It's giving me direction. It's asking me, does plant care decrease the number of health complaints? So it's giving me direction. I'm going to be looking in the left. I'm going to be looking on the left side of the distribution. So that means I'm going to have negative t-values. So here are the statistics. So Group 1, n is equal to 14, sample mean is equal to 17, and sample variance, s squared, is equal to 60.8. Group 2, the group with no control, n is equal to 16, sample mean is equal to 27, and sample variance, s squared, is equal to 59.3. So we're going to conduct the appropriate hypothesis test using alpha equal to 0.05, state our conclusion in terms of this problem, and make sure to use APA-style conclusions. So step 1, state our hypotheses. So here we go. Remember, this is a one-tailed test, and it's an independent samples t-test. So we can use one of two ways to state our hypotheses. So here's the null, where the population mean 1 is greater than or equal to population mean 2, or population mean 1 minus population mean 2 is greater than or equal to 0. Long-term care facility patients' perceived control over a plant does not decrease the number of health complaints. Or you could word it, plant care does not decrease number of health complaints for long-term care facility patients. Either way, not a problem. The alternative hypothesis, population mean 1 is less than population mean 2, or population mean 1 minus population mean 2 is less than 0. So in words, long-term care facility patients' perceived control over a plant decreases the number of health complaints, or plant care decreases number of health complaints for long-term care patients or facility patients. All right, so step 2, set the criteria, locate the critical region. Alpha is equal to 0.05. This is a one-tailed test. Degrees of freedom, n1 minus 1 plus n2 minus 1 is equal to 14 minus 1 plus 16 minus 1, which is equal to 13 plus 15, which is equal to 28. We have to look up on the t critical value table. And let me pull that up real quick. All right, so here is the t distribution table. I'm going to look for the proportion in one tail for alpha 0.05, which is right here, so this column. And I'm going to go all the way to the row where it says 28. So 28 is right here. There's 28. And so the t critical value, or the t critical value that I have to beat, is negative 1.701. Remember, we're looking at a one-tailed test in the left side on the left side of the distribution. So we need to beat a negative 1.07. I mean, a 1.701. 1.701. Negative 1.701 is what we need to beat. Okay, this brings us to step 3, which is calculating the test statistic. But before we calculate the test statistic, we need to find estimated standard error. But before we find estimated standard error, we need to do the pooled variance because we're dealing with unequal sample sizes, right? Remember? So there's an extra step involved with unequal sample sizes, right? So before we can calculate estimated standard error, we have to find the pooled variance. And there's the formula, or one of the formulas for pooled variance. Based on the numbers that we were given sample variances. So we can use this pooled variance where we are going to take the variance times its degrees of freedom plus the variance times its degrees of freedom and divided by the degrees of freedom from one group plus the degrees of freedom of the other group. So I've plugged it in right in here. So I've taken 60.8 times 13 plus 59.3 times 15 divided by 13 plus 15 gives us 790.4 plus 889.5 divided by 28, which gives us 1679.9 divided by 28, and that gives us a pooled variance. This is pooled variance of 59.9964. Now we can calculate estimated standard error. All right, so estimated standard error, we're going to take the pooled variances and they're going to be the same numerator for both, okay? So we're going to take 59.9964 and divide it by n. Be very careful here. This is not degrees of freedom. With estimated error, it's always we divide by sample size, okay? So 59.9964 divided by 14 plus 59.9964 divided by 16, which gives us 4.2855 plus 3.7498, all under the square root, which is equal to the square root of 8.0353. And so estimated standard error is calculated as 2.8347. Phew! Now we're ready to calculate the test statistic. So now we can do the t observed or the t obtained or the calculated t. Our sample means 17 minus 27 is in the numerator, divided by estimated standard error, which is 2.8347, gives us negative 10 divided by 2.8347, which gives us an obtained t or a calculated t of negative 3.5277. So, what's the decision? So step 4 is to make the decision. Negative 3.53 is much further in the tail than negative 1.701. Therefore, we reject the null hypothesis. Remember, another easy way to make the decision, without the negatives, just look at the absolute value of the t's. And if your absolute value of obtained t is greater than the absolute value of t critical, you reject the null hypothesis. Since we're rejecting, we have to provide a measure of effect size. So this time, we're going to do an estimated Cohen's d so you can see how that's done. And besides which, we have pooled variance too, so we can use our pooled variance, right? So estimated Cohen's d, the formula is sample mean from group 1 minus sample mean from group 2 divided by the square root of pooled variance. So 17 minus 27 divided by the square root of 59.9964, which is equal to 10 divided by 7.7457. It gives us an estimated Cohen's d of 1.291. This is a very, large effect. Remember that 0.8 is large. So this is beyond that, right? The 95% confidence interval, just like we did with the earlier example, we're going to take the sample mean differences plus or minus a margin of error. So 17 minus 27 plus or minus 1.701 times 2.8347, which is our estimated standard error. So that's going to give us negative 10 plus or minus 4.82. Our 95% confidence interval is negative 14.8 to negative 5.2. This brings us to the last part of the problem, the conclusion. So here's our conclusion. We reject the null hypothesis. There is sufficient evidence to conclude that long-term care facility patients' perceived control over a plant significantly decreased the number of health complaints. T with degrees of freedom of 28 is equal to negative 3.53. Probability less than 0.05. Estimated D is equal to 1.29. A very large effect. The 95% confidence interval is negative 14.8 to negative 5.2. Taking care of a plant led to a decrease in the number of health complaints for long-term care facility patients. And there you go. There's our independent samples example.